Welcome to Hartman Math. Today we're going to take a look at solving multivariable linear systems. Essentially it just means taking the previous lesson, the 7.1 and 7.2, which were primarily 2x2 systems, 2 variables, 2 equations, maybe going larger, 3 equations, 3 variables, something like that, possibly even larger. We're going to start with example number 8, data analysis, curve fitting, where we have polynomial form of a quadratic function, y equals ax squared plus bx plus c. We want our answer to look like that. And we know that these 3 points lie on the graph of that function. So the clue here is x, y. X, y, x, y. Plug in x, plug in for y. Each point generates an equation. So here we're going to square the -1 and add b times -1. See, and the -4 goes there. So that essentially becomes our, the first point generates that equation. And then substituting 0 in for x, y kills that, we're going to get c is equal to 1. And then 3 squared is 9, so 9a plus 3 times b plus c is equal to -8. And we've got 3 equations and 3 variables. But one thing we might notice right away is we know the value of one of the 3, and it's c because of a and b just disappearing in that equation. So we can take advantage of that because our goal here is to reduce this down from 3 equations and 3 variables down to 2 equations and 2 variables. And then back in 7.1 and 7.2, we reduced that down to 1 equation, 1 variable, and solved. So it's just a matter of reducing it down each time. Well, if we replace c with 1 in the top and the bottom one, we're going to get a minus b is equal to -5. 9a plus 3b is equal to -9. And now we can use the elimination method. I think I might want to eliminate b's, so I'm going to multiply the top equation by 3. We're ready to add, so 12a equals -24. That tells us that a is going to be -2. And then I think I might go back here so that I can find b. So go back to one of the equations, not the original where we have too much information, but right here where we have, if I can replace a with -2, I can then solve for the b. So I replaced a with -2. That's -1. If I add 1 to both sides, I get -b equals -3. So that means b equals 3. And we already know that c is 1. So we've got it all. Now go back to the original, replace a, replace b, replace c. Y equals -2x squared plus 3x plus 1 is our function. So in a linear system, there's a few different options for us as we solve. A lot of the time we do get exactly one solution. So like in the last one, we got a equals -2, b equals 3, c equals 1. That's one solution for that set of 3 variables. If something washes out and we get like a 0 equals 0 true situation, we can have infinitely many solutions. And then if we're doing the elimination or something happens and you get -5 equals 2, not true, you would get no solution. Example number 1, solve the system of linear equations. So in this one we've got different methods to choose from. If you look through the book, there's something called the Gaussian elimination, which is a little bit more complicated. We can just kind of stick with what we have and do some elimination. When I'm looking at elimination, I'm usually focused in on coefficients of 1 and negative 1. So I'm looking at this one right here and say that could be useful to eliminate the y's. So if I'm looking at the top two, I'm thinking if I multiply this one by 2, I can then add it to the top one. So we want to use a variable with a coefficient of 1 or negative 1 to eliminate. So I'm multiplying the second row by 2, and then I can add it to the first one. So 2 times that one plus that one. This is going to eliminate 2 times that one plus that one, 2 times that one plus that one. And we get an equation that only has x's and z's. And then the same thing here, I'm going to multiply this one by 3 to eliminate. So 3 times row 2, and add that to row 3. So 6x plus 9x, so 15x. 12z plus 5z, 17z. Multiplied by 3, negative 51 plus 9, negative 42. Now it becomes a little less obvious as we don't have a coefficient of 1 or negative 1. So we're looking for maybe what's like a least common multiple. And we could really choose to eliminate x's or z's at this point. If we chose to eliminate z's, I might choose to multiply the top one by 17 and the bottom one by negative 5. Multiply the top by 17, the bottom one by negative 5. Hopefully we got a calculator handy. Add, eliminate, add. Divide the 78 into the 312. It goes in nicely. So x equals 4. Go back to when we had 2 equations and 2 variables. Substitute that into either. I think my preference might be the top one. So that's 36. Subtracting that from both sides. 5z is equal to negative 30. So z equals negative 6. Now we know x and we know z. We can go back into one of these. I think the middle one might be the easiest. 2 times our x minus y plus 4 times the z is equal to negative 17. 8 combined with the negative 24. And then we can just move that to the other side. And then divide by negative 1 on both sides. We do get y equals 1. So in this case, where it's not a word problem or anything like that, we're just solving. We want to answer as an ordered triple, since there are 3 variables ordered, so order does matter. X, comma, y, comma, z, definitely inside of parentheses to represent this as a point, and it actually would be a point in 3 dimensions. Example number 2. So we don't have a x or a y or a z that has a coefficient of 1, but I am noticing that with this 2x, the others are multiples of the 2x. So this one might be the one to go after and use and say, I'm going to use this one to eliminate the other x's. So if we multiply this one by negative 2, and add it to the top one, we're going to disappear. So multiply by negative 2. So negative 14y minus 3y. Multiply by negative 4z plus 10z. And then negative 76 plus 38. And we get our new equation. And then multiply by negative 3 and add to row 2. So multiply row 3 by negative 3, add it to row 2. Multiply by negative 3 and add, cancel. So negative 21y plus 8y negative 6z minus 3z. Calculator on that one, multiply by negative 3, add it to the 17, and we get negative 97 there. Kind of looking at the z, so I already like the fact that they're opposite signs. What would be the least common multiple between 6 and 9? It would be 18. So if we multiply this one by 3 and this one by 2, we're going to be able to eliminate. So top equation by 3. Don't forget the right side. That's where common place for errors. Bottom one by 2. Negative 77y is equal to negative 308. Divide that in. Y equals 4. Let's put that here. So negative 17 times 4 plus 6z is equal to negative 38. Negative 68, we'll add that to both sides. 6z is equal to 30, so z equals 5. It doesn't really matter which one we go back into here. My preference, I think, is going to be the bottom one, as we do have the smallest coefficient there. Or we're going to place y with 4 and z with 5. 28, 38, subtract that both sides. 2x equals 0, so x equals 0. Don't forget ordered triple. X, comma y, comma z, 0, comma 4, comma 5. Definitely checkable if you want to plug it into each one. Hit your calculator, equals 38, equals 17, equals 38. You can check and make sure that you got it right. Example number 3. Rashid invests $5,000 of his inheritance from his great uncle Ezekiel. He invests in stocks at 8%, bonds at 5%, and rare coins earning 7%. He expects an annual return of $355. He wants to invest 3 times as much in coins as in bonds. How much does he invest in each? Probably want to start with the let statement, the amount that he's going to invest here, the amount that he's going to invest here, and the amount that he's going to invest here. So X is the amount invested in stocks, Y is the amount invested in bonds, Z is the amount invested in coins, be specific. All right, now we got to start generating equations. We're going to need probably 3 equations since we have 3 variables. We do have an amount invested equation. He invests 5,000. Some here, some here, some here. So that's our first one. X plus Y plus Z, those amounts total the total amount. We also have an interest equation. So the amount of interest from stocks, which would be 0.08 times X, plus the amount from bonds, plus the amount from coins is going to be 355. Once again, I think I'm going to decimal bust that, multiply everything by 100 so that we can eliminate the decimals here. So 8x plus 5y plus 7z is equal to 35,500. And we need one more equation. He wants to invest 3 times as much in coins as bonds. So coins needs to be amount 3 times what we have in bonds. We're talking about amounts, X, Y, and Z. So Z, the amount in coins, is going to be 3 times what was put in bonds. So knowing that, if we replaced each of these z's with 3y, then we'd have these two equations with only x's and y's. This is our substitution. So x plus y plus 3y is equal to the 5,000. And then 8x plus 5y plus 21y is 35,500. Seems like it might be easiest to eliminate the x's. So if we multiply top by -8 and add them, we're going to get -6y is equal to -4,500. Divide by -6. We get our y amount, which is 750. Pretty easy to find z. 3 times that gets us the z, 2250. And then if we put that there and there, and we know we're adding up to 5,000, I think x is going to come out to be 2,000. So make sure we specify $2,000 in stocks, $750 in bonds, $2,250 in coins. And you might be asking, well, if you get the most in stocks, why do you want to put everything there? I think he's trying to minimize risk and diversify just in case the stock market goes in the tank. That's it for today. I'll see you next time.